They say the ocean forgets nothing. But if that's true, then why does it stay so quiet about what happened here 250 million years ago, when nearly all life vanished from its depths? Perhaps it's because memory, like sediment, hides its truth beneath weight and time. So, before you get too comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. And tell me, where in the world are you listening from tonight? The story begins in silence, not the silence of peace, but the one that follows an ending. The Permian world had just died, the greatest extinction in the history of Earth. 9 out of 10 creatures gone, coral reefs reduced to dust, and the seas turned to dark chemical soups where oxygen could no longer breathe. It was not a moment, but an age, a death that lingered for millions of years. What rose after it should not have existed. Yet something did. From this stillness, from this black quiet where no current moved, the Triassic seas began to whisper again. In layers of limestone and shale, scientists find the trace of that resurrection. Scales imprinted like ghosts, teeth sharper than time, vertebrae arranged in spirals like forgotten prayers. But the mystery is not that life returned. It's how fast it did. Within just a few million years, the oceans, once emptied, were alive with monsters. Enormous, elegant, and cruel ichthyosaurs, Nothosaurus, Thalattosaurus, names that sound like spells from a language we no longer speak. Their fossils emerge from the desert stones of Nevada, from the cliffs of Monte San Giorgio in Switzerland, from the valleys of China. But there's a gap, an absence in the record. These creatures appear not as beginners, but as masters. Their bodies are already perfected for the sea, streamlined, predatory, designed for depth. How could evolution move so quickly after such devastation? How could a planet gasping for air give birth to swimmers shaped like torpedoes, with eyes that saw in darkness and spines that told of endurance no experiment could explain? Scientists speak of rapid adaptive radiation, the idea that survivors evolved fast to fill empty ecological roles. But when they touch the stone, when they brush the dust away from bone, even they admit there's something strange about how the story begins. There are no fossils showing the awkward, imperfect stages of transition. The line between land and sea is blurred, as if the ocean simply reached up, took the reptile in its arms, and taught it to breathe again. Some call it luck. Others call it inevitability. But perhaps it was memory. The ocean remembering what it had lost. The great dying had erased most forms of life. Yet it didn't erase the pattern. In the sediments of time, life is written in rhythms: extinction, silence, renewal. The Triassic was one of those rhythms, a pulse beating in the planet's long recovery. Volcanoes still bled across the continents, releasing carbon that warmed the sky. The continents were fused into one, Pangaea, a single world of endless shores. But the coasts were dangerous, volatile margins where life experimented with forms both familiar and alien. Imagine standing there, a shore without birds, without grass, without sound. The air thick with methane and heat. You look out to sea and see nothing, only the reflection of red clouds on black water. Then something breaks the surface, a shape too fast to follow, vanishing before the mind can understand it. The first predators of the New World. Practicing their hunger, paleontologists say it started small, lizard-like reptiles sliding into lagoons to escape the heat. But the bones they've found suggest a different beginning. Ichthyosaurs longer than buses, already powerful enough to dive hundreds of meters. Already built for open ocean. Where, then, are their ancestors? Why is the record missing? Some think the fossils are simply lost, buried in rock not yet found. Others whisper about a deeper erasure. The Triassic seas were volatile. Tectonic shifts swallowed coastlines. Entire basins vanished into Earth's mantle. Could the evidence of earlier forms have been consumed, rewritten by geology itself? If so, what we see now might be only the second chapter of a much older story. In Nevada's Fossil Hill, an ichthyosaur called Cymbospondylus youngorum was discovered, an immense creature 30 meters long, rivaling the size of modern whales. It lived just a few million years after the extinction. That is too soon, most admit, for such size to return. Too soon for the ocean to carry a giant again. The scientists who studied it called the find astonishing. They described it as the earliest evidence of gigantism after the mass extinction. Yet the eyes of the fossil seem to say something else, something ancient, almost knowing. We are told evolution is blind. But what if it remembers? Beneath every epoch lies the suggestion that the Earth itself guides what returns. When the seas open again, they do not start from nothing. They echo. They restore old shapes with new flesh. And perhaps, within that deep, wordless intelligence, the ocean recalls the body plan of dominance, the outline of a hunter drawn from memory, not invention. There's a quiet tension in these fossils, a sense of déjà vu in stone. The Triassic Ocean looks familiar, yet alien. The creatures are not the dinosaurs that would later dominate land, nor the sharks that still rule today. They belong to an age that seems to have rehearsed both, and then, almost as quickly as they appeared, some of them vanish again. Species known from only a few specimens, their lines broken mid-sentence. Was it bad luck? Or something deliberate? A pattern repeating? A rise and fall written into life's very code? Maybe the ocean doesn't want us to know. Maybe that's why it keeps its oldest secrets buried beneath miles of pressure and silence. And as the waves close again, as the last light fades through the dark water, you can almost hear it. The sound of breath returning to a planet, slow and deep, as if the Earth itself is waking from a dream. But if the Triassic was a dream, whose memory was it? And why, after so much death, did it choose to begin again with monsters? The ocean, when it remembers, does not speak in words. It speaks in shapes, in the curve of a spine, in the symmetry of a skull, in the logic of fins that move as though they had never known the land. That is how the Triassic seas began to tell their next story, one vertebra at a time. The silence that followed the great dying was breaking. New rulers were emerging, born from the ruins of extinction. But their birth was too perfect, too sudden, as if someone had skipped ahead in the book of evolution. When scientists first uncovered ichthyosaur fossils in the 19th century, they thought they had found the remains of fish. The bones looked too sleek, too fluid, to belong to reptiles. But the more they studied, the more contradictions they uncovered. These were air breathers, warm-blooded perhaps, creatures that nursed their young, just as mammals would millions of years later. And yet, they ruled the seas while mammals were still a whisper in the genetic code. How could that be? In the cliffs of southern China, paleontologists found Carterhincus, a small ichthyosaur-like creature with stubby fins and flexible wrists, an evolutionary half-step between land and sea. But its presence only deepened the mystery. If Carterhincus was transitional, then where were its ancestors? The rocks before it were empty, barren of evidence. The Triassic Ocean seemed to have conjured complex swimmers from nowhere. In Nevada's mountains, Once the floor of a shallow Triassic sea, the fossil record told a similar story. The ichthyosaurs there were already giants. Streamlined, hydrodynamic, efficient. Some had eyes larger than a human head, perfect for hunting in the lightless depths. Others had rib cages shaped to withstand pressure at unimaginable depths. There were no clumsy intermediates, no mistakes. It was as if evolution had cheated, bypassing its own rules. Scientists explain it through the idea of evolutionary opportunism. After the mass extinction, so many ecological roles lay empty that the survivors evolved at unprecedented speed. But that explanation carries a quiet discomfort. Rapid adaptation is one thing, but entire ecosystems rebuilt from ashes, complete with apex predators and food chains, in just a geological instant. That borders on the miraculous. Perhaps that's why the ichthyosaurs feel so alien to us. They are not ancestors of whales or dolphins, though they resemble them. Their similarity is an echo, a rhyme across time. It suggests something haunting, that when conditions repeat, life replays its favorite melodies. The ichthyosaurs filled every niche of the ocean. Some were small, like the delicate Myxosaurus, darting through coral lagoons. Others were immense, like Shonisaurus, whose bones now rest in Nevada's dry air, a ghost of an ocean long gone. They hunted ammonites, those spiral-shelled cephalopods that drifted like silver lanterns through the sea, and smaller reptiles, even their own kind. Fossilized stomach contents show bones of other ichthyosaurs inside them. The sea, even reborn, had already learned hunger again. But beyond their predatory grace lies a deeper, more philosophical puzzle. Evolution is said to proceed through random mutation, through blind chance sculpted by selection. Yet the ichthyosaurs seem carved by intention. They were not fumbling experiments. Their design was balanced, streamlined for speed, but heavy enough to dive deep. They gave birth to live young, head first, in the open ocean. A behavior requiring a precision of anatomy and instinct far beyond simple adaptation. Some paleontologists whisper that what we see in the ichthyosaurs is not random at all, but the planet's way of remembering efficiency. When environments collapse, nature restores the patterns that worked before. Whales, millions of years later, would trace the same outline. As if the ocean had kept a copy of the blueprint. But what if it's more than memory? What if something deeper, older, survives every extinction? Something like a seed hidden in the genome of life itself, waiting for conditions to awaken it. There are fossils that hint at this continuity. In the Alps, bones of Triassic ichthyosaurs show dense networks of blood vessels, an adaptation for regulating body temperature, seen in modern mammals and birds. But how did such complexity arise so quickly? Some researchers suggest that ancient lineages carried dormant genes, unused instructions that could be activated when the world demanded it. Evolution, then, would not be entirely blind. It would be forgetful, perhaps, but capable of remembering when reminded. In that sense, the Triassic Ocean becomes a metaphor for resilience. After total destruction, life did not rebuild from nothing. It reopened a forgotten library. Every bone, every scale, a sentence borrowed from an older text. And yet, among this beauty, there were horrors. Fossils of Nothosaurs, slender, long-necked predators, reveal bodies designed for ambush, with jaws filled with needle teeth perfect for seizing prey in shallow lagoons. Their elongated ribs formed a flexible cage, allowing them to twist and lunge like serpents. To watch them feed, if one could, would be to witness the ocean rediscovering cruelty. Then came the placodonts, their teeth broad as cobblestones, their jaws made for crushing shells. Some had armored plates along their backs, early prototypes of the turtle's shell. Others, like Henodus, looked almost peaceful, flat, slow, herbivorous. But even they carried the signature of survival etched into every bone. These were the architects of the new ecosystem. From plankton to predator, from coral to scavenger, the Triassic seas were a world reinvented. But beneath their rhythm, something was still wrong. The chemical composition of the water fluctuated violently. Carbon dioxide levels rose and fell. Entire reefs appeared, flourished, and died within a few millennia. The balance that held this world together was fragile. When we look at Triassic fossils under microscopes, we see growth rings, like those of trees. They show a pattern of stress, years of plenty followed by years of starvation. The ocean itself was unstable, its chemistry erratic. And yet, amid this chaos, the monsters thrived. Perhaps that's the paradox of survival, that only those who can endure uncertainty become rulers of the next world. The ichthyosaurs and nothosaurs were not merely adapted. They were forged in crisis. Every breath they took, every heartbeat, was a defiance of extinction. But evolution is not sentimental. It creates, it erases, it creates again. Even the giants of the Triassic seas would one day fall to silence. Their fossils tell us how they lived, but not why they disappeared. And so, we're left staring into the fossil's eye socket, that empty orbit where the sea once shimmered. It's like looking into a mirror polished by time. You can almost see movement there, currents shifting beneath the rock, as if the creature is dreaming still. Somewhere in that dream lies the answer to how the Triassic ocean rose from nothing and gave birth to giants that should never have existed. And as we listen to the faint whisper of the waves, we're forced to wonder, did life truly begin again? Or did something ancient simply return, wearing a new face? The sea was no longer silent. By the middle of the Triassic, it had learned to breathe again, to hunt again, to dream again. Beneath a red sun and skies thick with volcanic haze, its surface shimmered like metal, concealing the chaos below. This was the world that followed resurrection, a place where balance had not yet been invented, where every creature was an experiment. The oceans were full again, but they were restless, alive with unfinished ideas. And in those churning shallows, the hunters returned. The first of them were the Nothosaurs, lithe, serpentine reptiles that moved with the precision of nightmares. Their long necks cut through the water like whips. Their jaws were narrow, filled with curved teeth designed not to crush, but to hold. They waded near reefs, in lagoons, and at the edges of collapsing continental shelves, drifting as if dead until the instant of strike. What they hunted was not always known. Fish, yes, but also other reptiles, perhaps even their own kind. Fossils found in China show bite marks in nothosaur bones, teeth embedded in bone of the same species. Cannibalism, it seems, was one of evolution's first instincts. Imagine one moving beneath you, its body pale and sleek, its eyes unblinking in the dim light. Its movement is almost too smooth, too certain, as though guided by memory rather than instinct. Some of them, like Nothosaurus giganteus, reached lengths of 7 meters, gliding between seagrass meadows and shallow slopes that would one day rise to become the Alps. Their fossils rest now among mountain peaks, silent reminders that what is stone today was once a breathing sea. But even the Nothosaurs were not alone. They shared the Triassic waters with a growing cast of strange creatures. Placodonts with teeth like paving stones, Thalattosaurs with crocodile-like snouts, and proto-turtles beginning to armor themselves against this new age of predators. Each seemed to represent a different experiment in survival, as if the ocean was testing which design would last. In Monte San Giorgio, Switzerland, paleontologists uncovered a graveyard of these creatures, their bones layered like verses of an epic. Some skeletons are nearly complete, so exquisitely preserved that their last moments seem frozen mid-motion. Others are shattered, scattered, their bones rearranged by time, or perhaps by the violence of death. The rock itself holds a strange texture, thin layers of black shale alternating with limestone, each marking a pulse of the ancient sea. Within those layers lie the records of boom and collapse, of ecosystems rising and falling like breath. From that record, scientists know that the Triassic seas were unstable. Oxygen levels fluctuated. Temperatures swung wildly. Entire coastlines appeared and vanished as volcanic eruptions reshaped the continents. It was a world that demanded resilience. But resilience, for life, often means transformation. And transformation always comes with loss. Some fossils showed deformities, bones twisted or fused, signs of stress during growth. Perhaps the oceans were toxic, heavy with metals from volcanic vents. Perhaps radiation from an unstable atmosphere reached the shallows. The evidence suggests that life was adapting too quickly for comfort, evolving on the edge of collapse. And yet, in that tension, nature sculpted perfection. It's in that crucible that the next monsters emerged. Stronger, faster, and more refined. The ichthyosaurs, once rare, multiplied and diversified. Nothosaurs gave rise to their larger cousins, the plesiosaurs, whose long necks and vast flippers would one day dominate the Jurassic. But in this early stage, the competition was still open. The Triassic Ocean was a testing ground for power. One of the strangest among them was Lariosaurus, found in the rocks of Italy. Its short neck and paddle-like limbs suggest it swam awkwardly, staying near the surface. Yet its ribs were heavy, weighted for diving. Some researchers think it hunted close to shore, ambushing fish in bursts of speed. Others think it was a transitional form, a species caught between worlds, neither fully marine nor fully terrestrial. Its story ends abruptly in the fossil record, as if erased mid-sentence. Every discovery from this period adds another contradiction. Evolution appears to move forward, yet evidence disappears as quickly as it's found. Some sites show species flourishing for only a few 100,000 years, barely a blink, before vanishing. It's as if the ocean kept changing the rules, refusing to let any one form dominate too long. And still, something unseen guided the pattern, as if the sea itself was choosing its champions. In the strata of the Eastern Alps, there are layers where no fossils appear at all, periods when life seems to have withdrawn completely. Scientists call them black zones. They may represent anoxia events, moments when the ocean ran out of breath. To the mind that looks through stone, it feels like punctuation, as though nature paused between experiments before beginning again. The Nothosaurs thrived until around 210 million years ago, when they began to fade. By then, new hunters were emerging. Early plesiosaurs, with shorter bodies and vast, wing-like flippers. They swam not with side-to-side strokes like reptiles, but with an elegant, undulating motion that would later inspire myths of sea serpents. The Triassic was transforming again, and with it, the identity of the ocean's rulers. But even as the fossils tell us what lived, they tell us almost nothing of why. Why did certain lineages persist? Why did others vanish so suddenly? In one layer, you find abundance. In the next, silence. Some researchers suggest environmental shifts, rising carbon dioxide, volcanic winters, fluctuating sea levels. Others whisper of unknown factors, diseases, magnetic reversals, cosmic radiation. There are even those who suspect we may never know because the evidence itself was destroyed. The sea does not archive its secrets gently. In one rare fossil, a nothosaur lies with its neck twisted violently backward, as if struck by force in an instant. Nearby, a smaller creature is preserved mid-swim, untouched. Both entombed together, frozen in death but separated by intention. It is impossible to say whether it was an accident, a predator, or something else entirely. But in such scenes, time itself feels deliberate. The Triassic Sea was not peaceful. It was watchful. Each new creature seemed to carry in its form both memory and warning, as though it had been made aware of how fragile existence could be. Perhaps that is why, when we look at their fossils today, we feel an unease that goes beyond curiosity. These were not the naive beginnings of life's recovery. They were survivors of an apocalypse, and their eyes, even in stone, seemed to remember it. Every fin, every rib, every tooth is a message written in the grammar of endurance. It tells us that survival is never gentle. It demands transformation so complete that the past becomes unrecognizable. And so, as the Triassic Sea is filled with these sleek, efficient predators, one cannot help but wonder, what price did the planet pay for beauty so lethal, so immediate? When life rushes back too quickly, it leaves ghosts in its wake. And maybe those ghosts are still with us. In the myths of sea serpents, in the shapes that haunt the deep, in the recurring patterns evolution cannot seem to forget. Because every resurrection, no matter how miraculous, carries the echo of something that refused to die. By the time the Triassic seas reached their full bloom, the world above them had become almost unrecognizable. The continents were no longer separate lands, but one vast fused mass, Pangaea, a single supercontinent surrounded by endless ocean, wrapped in heat and ash. From orbit, if one could have watched then, it would have seemed like a sleeping giant, scorched along its spine, bleeding magma into the sea. And in that molten silence, evolution was still at work, sculpting its new empires beneath the waves. They were the architects of fear, the armored beasts and shell crushers, the ones that did not chase but waited, patient as time itself. Among them were the placodonts, creatures built like living anvils. Their jaws were blunt, lined with teeth that looked like river stones, perfect for cracking the hard shells of ammonites and mollusks. Some were small, no longer than a human, while others, like Placodus gigas, grew into formidable tanks of muscle and bone, covered in bony plates that shimmered beneath the surface like scales of forged bronze. It is strange to imagine beauty in such shapes. They were neither swift nor graceful, but their power was quiet, an endurance that did not need speed. They remind us that dominance in nature does not always belong to the fastest or the fiercest, but to those who can wait out the chaos. In the same water swam the Thalattosaurs, long-bodied reptiles with tails made for steering through currents, their skulls narrow and sharp. Some had teeth fine as needles, others heavy and crushing, adapted to the shifting prey of a changing ocean. Fossils of these creatures lie scattered across the world now, from the Pacific coast of North America to the limestone shelves of Europe, silent witnesses of a kingdom that once stretched from one end of the earth to the other. Each of these species seemed to have been designed not for comfort, but for survival in flux. The Triassic Ocean was still volatile, its chemistry unstable. Algae blooms turned seas toxic. Oxygen dropped. The water sometimes shimmered green with bacterial light. Yet, these creatures persisted. Their bones bear signs of stress and adaptation. Denser ribs for buoyancy control. Reshaped jaws for new diets. Eyes adjusting to dimmer light. Nature, it seems, was rewriting her own script with every generation. But amid that adaptation, there is something haunting. Fossil layers show rapid bursts of evolution, followed by sudden extinctions. Species appear, dominate, vanish, and are replaced by eerily similar forms, as if the sea itself could not decide which version of life it preferred. Some scientists have called it evolutionary restlessness. Others suspect a pattern, almost rhythmic, like the ocean inhaling and exhaling forms into existence. In that rhythm, something magnificent appeared. Along the shallow coastlines of Pangaea, a new hunter emerged. Sleek, powerful, and utterly unlike anything before. It was called Thalattoarchon saurophagus, meaning the lizard-eating ruler of the sea. Discovered in Nevada's desert, its fossil told a story of pure dominance. Measuring 8 meters long, with jaws capable of devouring other marine reptiles, it was the apex predator of its time, the first true ruler of the post-extinction ocean. The scientists who described it were astonished. Thalattoarchon appeared just 8 million years after the Great Dying, an evolutionary instant. How could an ecosystem recover so fully, so violently, so soon? Apex predators are supposed to come last in the sequence of rebirth, after food chains stabilize. Yet here it was. Proof that chaos itself could create kings. The bones of Thalattoarchon show power and precision. Its teeth were not made for grinding or tearing. They were for slicing, clean and deliberate. They fit into one another like the blades of a trap. Its skeleton, though massive, was streamlined, suggesting agility. This was not a clumsy survivor. It was an artist of violence. Perhaps that is the unsettling truth about nature. Destruction breeds refinement. After catastrophe, what returns is rarely simple. It carries the memory of death within it, like a scar turned to armor. The Triassic seas, for all their vitality, were a theater of unease. Volcanoes along Pangaea's rift zones darkened the skies. Methane released from the deep ocean altered the climate. Coral reefs, newly formed, flourished briefly, then died in waves of acidification. The planet was learning to breathe in rhythm again, but every breath carried toxins. And still, life adapted. Each collapse was followed by reinvention. Even as the monsters of the Triassic evolved, their own futures were already written in the chemistry of the sea. Carbon isotopes from that era show periodic crashes, moments when oxygen levels plunged, when temperatures spiked by several degrees in just centuries. Every time, new species vanished, and others rose in their place. To the rocks, these are just lines of data. But to the listener, they are the echoes of pulse and panic. The heartbeat of a world unsure whether it was alive or dying. Perhaps the greatest mystery is not that these creatures lived, but that they left so little trace of themselves behind. Many fossils show only fragments. A rib cage without a skull, a jaw without the rest of the body. Some species are known from a single specimen. It is as if the ocean allowed only glimpses before withdrawing them again, as though reluctant to be remembered. What remains tells a strange story of convergence. Placodonts with turtle-like shells that would vanish, only to reappear millions of years later in true turtles. Thalattosaurs with crocodilian snouts that foreshadowed later marine predators. Ichthyosaurs echoing dolphins long before mammals existed. Every form of life seemed to be rehearsing a pattern that would repeat through time, as though the sea itself was dreaming its future over and over again. And maybe that's what the Triassic really was. A rehearsal. A stage where evolution tested its most daring ideas. A world haunted by the memory of extinction, yet obsessed with creation. But beauty and terror were never separate things in that world. The ocean glowed under the heat of a sky that refused to cool, and in that crimson shimmer, you could have seen the shapes of predators gliding silently, their reflections bending in waves of smoke and salt. The water carried the taste of metal and memory. The air above it was heavy, trembling with storms that smelled of sulfur. If you had stood on one of Pangaea's coasts then, perhaps near what is now modern-day Morocco or Texas, you might have seen a placodont rise from the water, its shell glinting gold beneath a dying sun, and beyond it, the darker silhouette of something larger, deeper, faster, slipping beneath the horizon. A quiet dominance that asked for nothing but endurance. And as night fell over those alien coasts, the sea kept its secrets. The hunters slept in shallow bays, the scavengers drifted beneath them, and somewhere in the abyss, new forms were already gathering, shapes the world had not yet seen. The Triassic was not finished. Its seas were still writing, still revising, still dreaming of what might come next. And if the ocean's language is indeed one of memory, then every ripple that touched those shores was a sentence in an unfinished story. A story that would end in fire and begin again, just as it always had. Because the ocean does not forget. It only waits for us to listen. The ocean remembers through fragments, not in full sentences, not in clarity, but in broken syllables of stone. Fossils are its half-spoken words, its pauses, its echoes. When we read them, we think we understand, but what we truly see is what time has allowed us to keep. Everything else, the soft bodies, the colors, the sounds, the ways these creatures moved, is gone. What remains are ghosts caught mid-breath. Paleontologists often describe the Triassic fossil record as incomplete. But incomplete is too polite a word. It is fractured, uneven, erased in places where history should have been. The seabed that once hosted these monsters has been folded, lifted, crushed, and burned by geological time. Entire ocean floors now lie high among mountain peaks. Others have been swallowed completely, pulled back into the Earth's mantle. The Triassic seas may have birthed empires of life, but their archives are shredded manuscripts scattered across continents. What we do know comes from strange and distant places. Northern Italy, the Swiss Alps, China's Yunnan province, the Nevada desert. All of them share one thing. They were once the edges of the Panthalassic and Tethys oceans, shallow places where life clung to sunlight. The fossils there are often found in slabs of limestone, pressed flat like forgotten pages. But between them lie missing paragraphs, entire eras without a trace. The more we uncover, the more we realize how little survived. In Monte San Giorgio, a hill that now overlooks Lake Lugano, the stone itself hums with memory. Each layer is a chapter: coral reefs, lagoons, coastal muds, then darkness, an interruption. There, paleontologists find sudden die-offs, species frozen in moments of crisis, fish piled together, their fins outstretched as though gasping for air, reptiles contorted, bones twisted, mouths open, oxygen depletion, perhaps, a toxic bloom, maybe volcanic gases rising through the water. Yet every time life collapses, it returns again, subtly changed, as if revising its own design. One fossil layer holds the remains of Mixosaurus, a creature caught between worlds, neither primitive nor modern, neither clumsy nor sleek. It was a transitional ichthyosaur, about 2 meters long, with both lizard-like limbs and dolphin-like flippers. Its skeleton tells a story of hesitation, of adaptation mid-flight. But it also holds a mystery. Myxosaurus appears across vast regions almost simultaneously, from Europe to China to North America. How did such similar species appear in places separated by entire oceans? Were they travelers carried by currents across Pangaea's shallow seas? Or are we seeing parallel evolution, life reinventing the same form in isolation? The answer remains buried. Every time scientists think they have found the origin, the trail vanishes again into geological silence. It is as though the Triassic Ocean were hiding its beginnings, offering only glimpses of what it once held. Beneath this scientific puzzle lies something more philosophical. The fossils we find are not evidence of life. They are evidence of survival. To fossilize is to endure two kinds of death. First, the death of the creature itself, and then the slow death of time, pressing it into permanence. What we study, therefore, are not just bones, but memories made mineral. Some of these memories contradict one another. In certain layers, we find fossils of creatures that should not coexist. Species from different habitats, or even different times, pressed into the same rock. Landslides, perhaps. Or maybe something stranger. The ocean folding its pages back on itself, rewriting what once was. The deeper we look, the more dissonance we find. Bones warped by tectonic heat. Skeletons stretched, compressed, or twisted until they resemble different species. Some paleontologists spend their careers trying to distinguish what belongs to nature from what belongs to pressure and chance. But sometimes, the distortions look too deliberate. Vertebrae aligned like sculptures, ribs curled as if in motion. It is difficult not to feel that the ocean, even as it erased, also composed. One of the most haunting fossils ever found from this period is not the skeleton of a predator, but a cluster of embryos, ichthyosaur young preserved inside their mother. In one, the smallest infant is halfway through birth, its tiny head emerging from the pelvic bones. The mother must have died mid-labor, sinking before she could finish giving life. Millions of years later, the rock still shows that moment. Birth frozen beside death, hope and ending conjoined in stone. It is a kind of poetry, if one can bear to look long enough. But even poetry has margins, and the Triassic left many. In parts of the record, entire families of creatures disappear without trace. The Thalattosaurs, for instance, once so diverse, fade abruptly from the fossil record. No mass extinction layer marks their end. No volcanic ash. No evidence of global catastrophe. They simply vanish, as if the ocean withdrew its permission for them to exist. That is what makes this epoch feel haunted. It is not only the creatures that died, it is the knowledge that died with them. The sea, for all its generosity, is a poor archivist. It keeps what it wants. It buries the rest. And yet, through the gaps, a pattern glows faintly, like light refracted through deep water. The Triassic seems to have been a rehearsal for the world that would follow. The rise of marine reptiles mirrors the later dominance of dinosaurs on land. The extinction cycles echo later ones in the Jurassic and Cretaceous. It is as if the Earth was practicing, testing its mechanisms of creation and destruction. The physicist David Raup once said that extinction is not a failure of life, but one of its normal operations. It's not the exceptions that matter, he wrote, but the recurrence. The Triassic, in that sense, was a recurrence itself. Life breathing in and out through catastrophe. Even today, the fossils from that era still whisper confusion. Chemical analysis of ancient sediments shows spikes in mercury and carbon dioxide, evidence of volcanic events. But other layers show calm stability, full of growth and abundance. It's as though the Earth alternated between breathing and holding its breath. And when we examine those stones under ultraviolet light, we sometimes find traces invisible to the naked eye. Residues of cartilage, pigments, even the shadows of ancient blood. It is as if the sea, reluctantly, left fingerprints on its own silence. Perhaps that's all the ocean ever wanted, to be remembered, but not understood, because understanding requires clarity. And clarity is something the Triassic never offered. It was an age of contradictions, warmth born from catastrophe, beauty rising from ruin, abundance hiding extinction beneath it. When we look at its fossils now, bones curled inside rock, skeletons distorted like reflections in water, we are not just seeing prehistory. We are seeing the afterimage of a dream, the echo of something that once lived and refused to be forgotten. And maybe that's why the Triassic seas still haunt our imagination. Not because they're gone, but because they feel unfinished, like a story interrupted mid-sentence. Somewhere, beneath the pressure and stone, that story continues still. And perhaps, if we listen closely enough, the ocean will tell us what we were never meant to know. There are moments in Earth's history when the planet seems to turn against itself. When fire and water trade places. When the sea breathes heat instead of air. The Triassic was one of those moments. The fossils whisper of creatures rebuilding the world, but the rocks beneath them tell a darker story. Of oceans that boiled, skies that choked, and continents that cracked open like overripe fruit. It was a world still healing from catastrophe, and the wounds had not yet closed. The Triassic began as an age of recovery, but by its middle, it had become an age of fever. Volcanoes erupted endlessly along Pangaea's seams, their smoke drifting for years through the atmosphere, thickening the heat, dimming the light. Geologists call it the Carnian pluvial episode, a time when the skies themselves turned violent. Rain fell for centuries, acidic and warm, washing minerals from the continents into the seas. Rivers carried silt, carbon, and sulfur into the water, turning it cloudy, heavy, and strange. In those poisoned seas, something unexpected happened. Life didn't retreat. It adapted. The ichthyosaurs dove deeper. The Nothosaurs abandoned the coasts, and reefs built by new organisms rose from the murk. But the ocean's chemistry was unsteady. Anoxia, oxygen loss, spread through the depths, trapping life in narrow bands of survivable water. The upper layers teemed with predators, while below, decay ruled. The ocean had become layered like an ancient text. Life above, death below, and between them a silence that pulsed like a warning. The rocks from that time record the imbalance. They are stained red and black, bands of iron oxide and organic carbon that alternate like breaths. To the geologist, they read like vital signs, a planet in distress. To the storyteller, they read like confession, Earth remembering what it had done to itself. The sea, for all its grandeur, was suffocating. And yet, in that suffocation, new power emerged. Shonisaurus, the largest of the ichthyosaurs, appeared during this period. A creature longer than a school bus, its flippers shaped like wings. Its fossils are found today in Nevada's high desert, far from any ocean, the remnants of a vanished abyss. Hundreds of individuals have been found together, as though gathered in death. Some scientists think they came here to give birth. A Triassic nursery wiped out by sudden catastrophe. Others think it was a mass stranding, giants trapped by retreating tides as oxygen collapsed. Either way, the image remains. A graveyard of leviathans, silent beneath what was once a sea of fire. When volcanic gases entered the atmosphere, they didn't just darken the sky, they thickened it. Carbon dioxide levels soared to nearly 10 times modern levels. The oceans absorbed that carbon, turning acidic, dissolving shells, and bleaching reefs. And still, the creatures endured. Their endurance feels less like resilience and more like obsession, as if life itself refused to surrender, even to poison. There's a strange symmetry in these cycles. Each eruption, each flood, each collapse seemed to precede innovation. After devastation, new forms emerged. More efficient hunters, faster swimmers, more complex ecosystems. It was as though the Earth required pain to evolve. Scientists still debate why these cycles occurred. Some point to the Central Atlantic Magmatic Province, a massive volcanic system that erupted near the end of the Triassic, releasing enough lava to cover millions of square kilometers. Others speak of methane hydrates locked in seafloor sediments, released in bursts that spiked global temperatures. Whatever the cause, the result was the same. Life was forced to reinvent itself again and again, each time more specialized, more desperate, more exquisite. One study of Triassic rocks in Austria found thin layers of ash embedded in marine sediments, alternating with periods of calm. The pattern suggested that volcanic eruptions were nearly rhythmic, like the Earth exhaling every few thousand years. Between those breaths, ecosystems flourished briefly, only to be erased again. When researchers plotted these cycles, they found a pattern eerily similar to modern climate oscillations. The same planet that suffocated its Triassic seas breathes now through ice ages and warming periods, as if unable to stop the rhythm it began so long ago. And through it all, the sea remained the great witness. In its upper reaches swam the survivors, placodonts with shells thickening against acidity, thalattosaurs migrating toward cooler waters, ichthyosaurs diving into the depths where pressure preserved stability. But below them, the water grew still. In anoxic zones, bacteria consumed what little oxygen remained, creating toxic byproducts that turned the sea green, then black. Those same bacteria would one day fossilize as thin films of pyrite, fool's gold, lining the bones of the creatures they killed. To walk through a Triassic fossil bed today is to walk through the residue of those oscillations. Life layered upon death, stability upon collapse. The stones glitter with iron, the air smells faintly of sulfur, and every bone seems to hum with tension. The fossils are not peaceful. They are restless. They feel like memories caught mid-transformation, like sentences rewritten halfway through. Somewhere within this chaos, the ocean began to organize itself again. The deep seas remained lifeless, but the surface world bloomed. Plankton diversified, corals began to return, and complex food webs took shape. It was as if the sea, exhausted from rage, decided to rebuild in smaller, more cautious patterns. For a few million years, equilibrium returned. But equilibrium is an illusion. The end of the Triassic was approaching, and with it, another global reset. We often imagine extinction as a sudden event, a meteor, a fire, a crash. But in truth, it's a whisper, a slow suffocation that takes place over thousands of years. For the Triassic, the whisper was heat. The volcanic fields that had once created islands now covered half the globe. The air thickened until the world itself seemed to sweat. Temperatures rose past the tolerance of most species. Coral reefs dissolved again. The black bands returned to the sediments, marking the ocean's loss of breath. When the end came, it was quiet. The great predators vanished first. Those who required the most oxygen, the most prey. Then the smaller creatures followed. It happened not with violence, but with stillness. By the dawn of the Jurassic, nearly half of all marine species were gone. Yet out of that silence, something extraordinary emerged. From the survivors of the Triassic seas came the first plesiosaurs, true masters of the Jurassic oceans. Their long necks, their 4 powerful flippers, their serene movement through the water, all of it traced back to the resilience that the Triassic had forged. It's difficult not to see intention in such persistence, as if the Earth, despite its violence, wanted to be alive, as if every extinction was merely a rehearsal for endurance. The Triassic seas are gone now, folded into mountain ranges, buried beneath deserts, dissolved into myth. But their memory lingers in the salt of our blood, in the carbon that builds our bones, in the rhythms that still govern the planet's breath. Every heartbeat, every tide, every storm is an echo of that ancient pattern. The rhythm of destruction and renewal. Perhaps that is the oldest law of the ocean, that nothing truly dies. It only changes form, waiting for the next awakening. And as we listen to the waves today, soft, rhythmic, infinite, we might wonder, are they calming us or reminding us that the sea has burned before and it will burn again? When the fever of the Triassic finally began to fade, the sea seemed to rest, but only for a moment. Its silence was not peace. It was anticipation. Because in the shadows of that quiet, new predators were gathering, and what they brought would redefine what it meant to rule the ocean. The giants had returned, but these were not the same as before. They were faster, hungrier, and stranger, creatures born from disaster, carrying the memory of extinction in every cell. Their bones would one day be found in deserts that were once ocean floors. Nevada, British Columbia, the Alps. But when they ruled, they swam in a world that shimmered with violence. The shallow seas of the late Triassic were vast highways of life and death. Ammonites spun through the water like jeweled clocks, their spiral shells marking the passage of time. Shoals of fish moved in mirrors, turning as one, scales flashing like light through crystal. And among them moved the new lords of the sea, the apex predators that evolution had sculpted with ruthless precision. One of them was Thalattoarchon saurophagus, the ruler of reptiles. Its name means lizard-eating sovereign, and its jaw alone tells the story of its reign. Each tooth curved backward, blade-edged and sharp as obsidian. Fossils show that it could tear through bone and muscle with surgical ease. It didn't feed on fish or invertebrates. It hunted its own kind. The Triassic Ocean had become self-consuming again, a kingdom of predators devouring predators. But the mystery lies not in its brutality, but in its timing. Thalattoarchon appeared less than 8 million years after the Great Dying, too soon for ecosystems to rebuild so completely. Apex predators are supposed to come last, when food chains are mature, when stability has returned. Yet, here it was, arriving early, as if it had been waiting. Some scientists suggest that evolution simply moved faster after the collapse, that empty ecosystems invite chaos and innovation. Others whisper of a deeper pattern, that nature, when pushed to its limits, remembers its strongest forms first. If that's true, then Thalattoarchon was not new at all. It was memory revived, a shadow of the ancient predators that had ruled before the extinction. Its shape, its instinct, its hunger, each might have been inherited not from ancestors, but from the ocean itself. And it was not alone. Alongside it swam the first true plesiosaurs, reptiles with long necks, compact bodies, and 4 powerful flippers that beat in unison like wings. Their design was unlike anything before them, a body built for endurance, not speed, for grace, not rage. They were slower than ichthyosaurs, but more maneuverable, able to hover in the water like thoughts suspended in time. In them, the ocean had invented elegance. It's easy to forget that this was still a world in turmoil. The continents were drifting apart, tearing Pangaea into fragments. Rifts opened, seas widened, and with them came new habitats. Every coastline was alive with change. The water's chemistry fluctuated, its temperature swayed, its tides grew stronger, and the creatures adapted in kind. In the deep layers of what is now Switzerland, paleontologists uncovered fossils of Nothosaurus giganteus and Cymbospondylus gaillardoti, predators that hunted in the same waters but in different ways. One sleek and serpentine, the other built for crushing prey with broad jaws. Their coexistence speaks to a world of competition finely balanced, a web of strategies where survival depended not on strength alone, but on timing, on subtlety, on knowing when to strike. The Triassic Ocean, in this way, resembled a mind, restless, experimental, full of memory and amnesia all at once. It created, destroyed, recreated. It repeated itself in patterns that feel almost conscious. And through that rhythm, the monsters evolved not as accidents, but as answers. One fossil, discovered in 2013 in China's Guizhou province, seemed to rewrite everything scientists thought they knew. It belonged to Guizhou Thiosaurus, an ichthyosaur that had swallowed another marine reptile almost as large as itself. The prey was preserved inside, its bones still articulated. It was the oldest known example of megapredation, one giant eating another. This single fossil proved that the Triassic Sea was already a world of giants feeding on giants. Evolution, it seemed, had skipped the middle stage entirely. The image is almost mythic. An ocean reborn from extinction, immediately filled with creatures capable of devouring one another whole. It's as though the planet had chosen not to rebuild peace, but to remember hunger first. And yet, there is beauty in that violence. Every predator carried the perfection of design. Streamlined skulls, flexible spines, rib cages that curved like the architecture of temples. Their bones were not crude. They were symmetrical, mathematical, almost artistic. When you look at a fossilized vertebra of Shonisaurus or Thalattoarchon, you can trace the geometry of motion, the precision of a creature shaped by need. Each curve, each joint, each groove speaks of a dialogue between chaos and purpose. That is the paradox of the Triassic Ocean. It was chaos organized into grace, but even the rulers were mortal. The same forces that birthed them, the heat, the gases, the unstable climate, would one day erase them. By the late Triassic, as volcanic activity intensified and the supercontinent began to split, oxygen levels dropped again. The deep seas stagnated. Surface waters turned acidic. The predators, built for abundance, found their world thinning. Their reign had lasted millions of years, but in geological time, it was a flicker, a single breath. Some survived into the Jurassic. Others vanished without a trace. Fossil beds record their absence as abrupt emptiness. Layers once rich with bone suddenly bare. Scientists still debate why. Some say it was the Central Atlantic eruptions, which darkened the skies and heated the planet beyond habitability. Others think it was the gradual poisoning of the ocean, a death too slow to leave a scar. Either way, when they were gone, the sea was changed. The memory of their forms would linger, reappearing later in whales, dolphins, and even the myths of sea serpents told by early humans. The image of the long-necked beast gliding beneath the waves would echo through millennia, resurfacing in legend after legend, as if humanity itself carried the ocean's dreams in its subconscious. And perhaps that is not coincidence. Our bodies are born of salt. Our blood carries the same ions that once filled the Triassic tide. The memory of those ancient hunters, of their silence and grace, is written in us as much as in the rocks. When we imagine monsters beneath the surface, maybe what we're really remembering is ourselves. Some ancient fragment of fear and reverence passed down from a time before thought. Because the sea has never stopped creating rulers, it only changes their shapes. Every age has its monarchs, some scaled, some furred, some clothed in glass and steel. But all of them emerge from the same rhythm, the same hunger that has driven life since the Triassic began to dream. And if you listen to the ocean now, when the waves roll against the shore at night, you might hear it. The faint echo of that ancient breath, deep and steady, as if the sea still remembers the sound of its kings. Because maybe it does. Maybe it always will. By the time the Triassic began to fade, the continents themselves were breaking apart, and the oceans were changing with them. The single, massive world of Pangaea was no longer whole. It was cracking open, bleeding molten light into the water, and the coasts were shifting with every generation. What had once been one vast shoreline became a labyrinth of lagoons and gulfs, where the newborn Atlantic breathed its first uncertain tides. The map of the planet was rewriting itself, and with it, the lives of everything that swam. The sea, once an endless stage of predators and prey, now fractured into smaller theaters. Inland seas rose and disappeared. Shallow reefs turned to deserts, then back to deltas again. Even the air felt unstable, filled with the taste of metal and dust. The Triassic world was not ending in a single moment. It was unraveling quietly, piece by piece, like a dream dissolving at dawn. In that unraveling, new coastlines were born. They stretched through what is now Europe, North Africa, and the Americas. Luminous, dangerous places where volcanic mountains met the sea in plumes of ash and steam. Rivers poured minerals into the water, and life adapted again, reshaping itself to fit the instability. It is from these shifting coasts that much of what we know about the end of the Triassic comes. Fossil beds from these zones, rich, chaotic, inconsistent, capture the last glimmers of that era before it fell silent. Among the fossils, scientists have found signs of stress, bones showing lesions from disease, teeth worn unevenly, skeletons smaller and thinner than their ancestors. The giants that had once ruled the sea were dwindling, and their young seemed weaker. Some paleontologists believe this was due to oxygen collapse, levels in the ocean and air dropping so sharply that even breathing became an act of struggle. Others suggest volcanic winters, when ash clouds dimmed the sunlight for years at a time, starving the food chains from the bottom up. In the black shales of eastern Greenland, the story of that struggle is still written. There, layers of sediment preserve alternating records of abundance and death, blooms of marine life, followed by sudden disappearances. Carbon isotopes spike wildly, suggesting bursts of carbon dioxide that turn the ocean acidic. Between each spike, thin bands of clay mark brief returns to normalcy, as if the earth was gasping for air. Then, silence again. The Triassic Sea, once fertile, had begun to betray its children. But what makes this period haunting is how gradual its violence was. There was no single blow, no asteroid, no firestorm to end it all. The extinction crept like a fever that no one noticed until it was too late. Species vanished, not because they were hunted or poisoned, but because the rhythm of their world changed faster than they could follow. Even the great ichthyosaurs, those masters of the open water, began to disappear from the fossil record. Their bodies, once designed for perfection, could no longer match the shifting chemistry of the ocean. They had grown too large, too dependent on stability. Nature, as always, favored the adaptable. And so, smaller species began to inherit the seas. creatures that could live in uncertainty, that could breathe in the gaps between disaster and calm. It's tempting to see tragedy in this, but there is also wisdom. The ocean was editing itself again, stripping away what could not survive constant change. And in that editing lay the blueprint for the world that would come next. On land, the first dinosaurs were spreading. Small, agile, watchful things that had learned to thrive in extremes. In the sea, their aquatic counterparts were doing the same. Early plesiosaurs, with necks that could coil like serpents, began to appear in the shallows. Crocodile-like reptiles, phytosaurs and their kin, patrolled the estuaries. Even as the old rulers vanished, new forms were already assembling, waiting for the Triassic to end so they could begin. The breakup of Pangaea also changed the ocean's heartbeat. With every widening rift came new circulation patterns, new currents that carried heat from the equator to the poles. The once uniform seas became divided, some warm, some cold, each a world unto itself. Fossils from high-latitude regions show adaptations unseen before. Thicker bones, deeper lungs, eyes larger than ever. Life was preparing for a more complex planet, and yet, even in this transformation, the past refused to die. The same shapes kept returning, the same sleek bodies, the same curved jaws, the same spiral shells, as if the sea, in breaking apart, was trying to remember how it had once been whole. In certain fossil beds of Austria and Italy, scientists have found mass burials, whole communities of fish, reptiles, and ammonites entombed together, as though caught in a single moment of suffocation. Some layers contain volcanic ash, suggesting sudden eruptions. Others show none at all. One possibility is methane bursts, massive releases from the ocean floor, triggered by heat or seismic activity. If so, these could have wiped out vast stretches of life in hours, leaving the fossil record as their only obituary. It's chilling to think of it. An ocean turning against itself in an instant. And yet, even here, the story is not purely one of death. Some species endured, adapting almost immediately after each collapse. The resilience feels unnatural, almost rehearsed. It is as though the genetic memory of survival had been encoded deep within them, life anticipating its own destruction and preparing accordingly. That instinct, that premonition, feels strangely familiar to us. We too sense when the world is shifting beneath our feet, even when the signs are subtle. Perhaps that awareness of fragility, of impermanence, is something inherited from those ancient survivors. As the Triassic drew to its close, the Earth was entering one of its great metamorphoses. The Central Atlantic magmatic province erupted across what is now Brazil, Morocco, and North America, flooding the continents with fire. Ash turned the sun red, the rain black. The ocean warmed again, this time beyond recovery. In less than 500,000 years, a heartbeat in geological time, most of the great Triassic species were gone. But extinction is not the opposite of creation. It is its shadow. The Jurassic dawned upon a planet remade. The seas were cleaner, deeper, more stable. And from the remnants of Triassic survivors came the great dynasties that would follow. The plesiosaurs, the pliosaurs, the early sharks and ammonites that filled the new oceans with motion and color. The silence left by the Triassic's death was not empty. It was fertile. When we look back now, from our own fragile age, the Triassic feels like both a warning and a reassurance. It tells us that even when the world breaks apart, life continues. It changes form. It migrates. It rewrites itself. But it endures. And perhaps that is the quiet truth written into the rocks. That every ending the Earth has ever known was only the beginning of something else. Because the sea, for all its cruelty, never stops dreaming. It only changes what it dreams of. Every bone is a sentence, and every fossil is a paragraph in a language that no one alive can fully read. The sea wrote its history long before we arrived to decipher it, and what we find now are fragments of syntax, verbs without subjects, memories without names. The Triassic Ocean speaks to us through the language of bones, and in that language, silence means as much as sound. When paleontologists lift a slab of limestone from Monte San Giorgio or Guijo, they are not just uncovering skeletons. They are holding a page torn from a book that the Earth has been rewriting for 250 million years. Some of those pages are smudged, overwritten by later chapters. Others are so faint that even under a microscope, they refuse to yield their secrets. But all of them whisper the same truth: that history is not preserved, it is translated. And translation is always imperfect. The bones we study today are not what they once were. They've been soaked in minerals, compressed by weight, heated, cooled, broken, and healed by time. They've changed substance entirely, becoming echoes of themselves. When we call them remains, we lie a little. They are not remains. They are reincarnations. The sea, in its endless patience, has turned life into stone without letting it die completely. And perhaps that is why the fossils sometimes seem alive. In certain Triassic deposits, skeletons are found in positions too dynamic to be accidents. Nothosaurs frozen mid-turn. Ichthyosaurs curved as if still swimming. Their spines are arcs of intention, not collapse. The scientists call it post-mortem distortion, the twisting of bodies by sediment and decay. But it's hard not to feel that the ocean itself sculpted these poses, arranging its memories into art. There's a kind of reverence in the way paleontologists describe these fossils. They talk about articulation, the degree to which bones remain in their living order, as if describing choreography. They measure each angle, each dislocation, trying to reconstruct movement from stillness. What they seek is not just anatomy, it is narrative. They are reading the grammar of motion, the syntax of survival. Some fossils, though, refuse to follow grammar. They contradict themselves. A bone from one species appears identical to another found thousands of miles away. Teeth that should belong to predators are found among the herbivores. In one site, a skull fits perfectly with the spine of another creature entirely. These anomalies are often dismissed as coincidence, but collectively they form a pattern. Repetition across distance, symmetry across time. It's as if evolution kept rewriting the same sentences, changing only a few words. Convergent evolution, scientists call it. Life reinventing successful designs over and over. But there is a poetry in that repetition too. The ichthyosaurs and dolphins, separated by hundreds of millions of years, share the same sleek outline. The placodont's armor foreshadows the turtle's shell. The same eye, the same curve, the same hunger appear again and again, as though memory itself had a hand in shaping them. Perhaps bones remember. In the Triassic seas, skeletons were more than structures. They were instruments of survival, tuned to the frequencies of the ocean. Bone density dictated how deep one could dive. Rib shape decided whether lungs would collapse or resist pressure. The sea composed its creatures as music, altering tempo, rhythm, and pitch until they resonated with the currents. What remains now are the notes, the silent score of a vanished symphony. Some researchers have begun to listen differently. Using CT scans and isotope mapping, they read fossils not as static forms, but as chemical diaries. The oxygen trapped in ancient bone reveals migration routes. The ratio of strontium shows what waters they swam in. The carbon preserves the flavor of their diet. A single vertebra, properly decoded, can tell where an ichthyosaur was born, how far it traveled, and what it ate the week it died. The stone becomes a memory device, a kind of data storage written in matter. But even this clarity deepens the mystery. When the data is plotted, it shows movements too long, too fast, too coordinated for simple instinct. Whole populations migrating across thousands of kilometers at once, synchronized without visible cause. It's as if the ocean itself conducted them, moving its orchestra of life in time with the planet's hidden rhythms. Temperature, magnetic field, the slow heartbeat of tectonic plates. There's a theory, not yet mainstream, that life does not evolve independently of Earth. It co-evolves with the planet's cycles, guided not by chance, but by resonance. The creatures of the Triassic might not have just adapted to their environment. They may have been shaped by the same forces that moved the continents and the tides. When the magnetic poles shifted, perhaps their sense of direction changed with it. When the ocean breathed carbon or sulfur, perhaps their metabolism sang in tune. If that's true, then every fossil is not just evidence of biology. It is evidence of collaboration, the Earth and its life, writing together. And yet, there are lines of that script we can never read. Some bones appear to hum with lost context, species so strange that even naming them feels arrogant. One partial skeleton from British Columbia, known only as Carterhinchus, still defies classification. Its limbs are neither fins nor legs. Its body is part swimmer, part crawler. It looks like an answer to a question we no longer remember asking. The more we learn, the less certain we become. The deeper we look, the older the mystery gets. Beneath every discovery lies another absence, another silence. The Triassic Ocean is not a story of beginnings and endings. It's a story of recurrences, of unfinished sentences written over each other until meaning itself becomes blurred. When paleontologists finish cleaning a fossil, they often sit in silence. They turn it in their hands, studying the texture, the weight. They know that what they hold is not just evidence of life, but evidence of time, the pressure of millions of years condensed into one fragile shape. That fragility humbles them. The creature they study survived the collapse of worlds, yet it can shatter at a touch. And perhaps that is why we keep returning to these stones, because they remind us that even perfection erodes, that every empire, be it reptile, mammal, or human, is written in dust. But the bones, for all their quiet, do not despair. They wait, patient, enduring, certain that one day the ocean will rise again to touch them. Because the sea never stops reclaiming what it made. It erases, it buries, it transforms. But it never truly forgets. So when the wind crosses the Alps or the deserts of Nevada and carries the scent of ancient salt, it is not imagination. It is memory. It is the ocean, breathing through the bones of its former children, reminding us that every story, no matter how buried, still waits to be read. There is a kind of silence that only arrives after exhaustion. A quiet so vast it feels like the world has forgotten how to breathe. The Triassic ended inside such a silence. For nearly 50 million years, life had been rebuilding itself out of ruin, sculpting new forms, filling empty seas with motion and color again. But even the ocean has limits. Beneath its shimmering surface, something was breaking. The final years of the Triassic were not marked by a single catastrophe, but by a long unraveling, a world coming apart by degrees. The air grew thick with carbon and heat. The continents split further. tearing open veins of molten rock that bled across what is now North America, Europe, and Africa. The eruptions came not in flashes, but in pulses. Each one released waves of carbon dioxide, raising global temperatures, acidifying the oceans, and dimming the light that reached the reefs below. The creatures that had survived so many cycles of collapse began to falter. The great ichthyosaurs dwindled first, their numbers shrinking as prey vanished and waters turned anoxic again. Their fossils, once common across the Triassic strata, became rare. Isolated bones, incomplete skeletons, lonely fragments of a world losing its rhythm. Even the smaller hunters, the Nothosaurus and Thalattosaurus, began to vanish. They left no clear trace of when or why. It was not a dramatic death, but a slow fading, as if the ocean were gently erasing them, line by line. Geologists studying the boundary between the Triassic and Jurassic periods describe a sharp black band, a layer of sediment rich in carbon and void of life. Above it, the rocks change composition. Below it, the story is different. It marks the point where the planet's breath caught, where oxygen fell to its lowest levels in millions of years. Some call it the silence layer. Others call it the ocean's pause. What happened beneath that layer remains an argument. Some point to the Central Atlantic Magmatic Province, the immense volcanic field that erupted at the time. Its lava flows still lie buried beneath modern coastlines, stretching from Brazil to Nova Scotia. The gases it released would have been enough to warm the Earth by several degrees, triggering acid rain and suffocating the seas. But perhaps it wasn't just fire that ended the Triassic. Perhaps it was memory itself. The weight of too many resurrections. Every cycle of destruction leaves its echo. The more often life rebuilds, the more fragile its foundation becomes. The Triassic had already endured so much: hyperthermals, anoxia, floods, extinctions, and each recovery demanded something in return. By its end, the ocean's resilience was spent. The chemistry that once nurtured life had become toxic. The rhythm that once sustained creation faltered. In that faltering, the ocean began to quiet. The reefs turned pale. Plankton thinned. The great ammonites, those spirals of time, dwindled into simpler forms. The predators that once ruled the waters now swam through deserts of their own making, searching for prey that no longer existed. It was as though the sea had lost interest in life. Some fossils from this period are found half-transformed, bones mineralized unevenly, suggesting rapid burial in sediments heavy with decay. The creatures they belonged to may have died during sudden oceanic stagnation, trapped between layers of unbreathable water. Their last movement was upward, toward light, but there was no oxygen left to find. When the end came, it was strangely gentle. No firestorm, no impact crater, just a slow and perfect stillness, spreading across the sea like sleep. The last waves of Triassic life folded into the black water and disappeared. What remained was emptiness. Yet, in that emptiness, something waited. Because the end of the Triassic was not the end of the ocean's dream. It was a clearing of space, a resetting of the stage. From the survivors, the smallest fish, the most adaptable reptiles, the ones that could endure heat and acid and chaos, would rise a new order. Within a few million years, the Jurassic seas would bloom again with new giants, plesiosaurs with necks like serpents, pliosaurs with jaws like thunder, sharks with spiraling teeth. The silence was only an inhalation before the next breath, but for the brief span when nothing moved, when even the current seemed to stop, the planet must have felt ancient beyond comprehension. Imagine standing at the edge of one of those dying coastlines, the air hot, the light copper-colored, the water flat as glass. No birds, no insects, only the occasional bubble from a deep vent far offshore. The sea, usually so restless, holds its breath. And beneath it, in the dark, the bones of the Triassic lie waiting. A museum the Earth has hidden from itself. Scientists who study this period sometimes describe it as eerie. The data stops abruptly, as though the record itself died. Sediments that once teemed with microfossils become barren. Trace elements vanish. It's not just life that disappeared. It's information. The ocean erased not only its inhabitants, but the evidence of their existence. That's why the transition from Triassic to Jurassic still feels unsolved. It's not merely extinction. It's amnesia. And what is amnesia if not a kind of mercy? Perhaps the Earth needed to forget in order to continue. To carry every extinction, every agony, every failed experiment would be unbearable. The sea, in its wisdom, remembers selectively. It keeps the beauty and lets the pain dissolve. When the first Jurassic creatures finally returned, they did so quietly, as if entering a sacred place. New species of corals built new reefs. Small ammonites spiraled through the shallows again. Tiny fish schools shimmered like rain. The world began to move once more, cautiously, humbly. The silence had not destroyed life. It had refined it, but deep beneath that renewal, the old Triassic bones remained, layered in black shale, sealed away like forgotten prayers. And sometimes, in the rare fossils where minerals formed crystals inside the skulls, there is a strange shimmer, a glittering where eyes once were. When light touches those stones, it reflects faintly, like a gaze returning the look. Perhaps it's imagination, or perhaps it's the memory of the ocean itself, seeing through the eyes of what it once lost, because the sea is the closest thing this planet has to eternity. It outlives mountains, civilizations, and names. It buries and resurrects in equal measure. And though the Triassic ended long ago, its echoes still pulse in every wave, in every storm, in every tide that reaches the shore. When you stand by the ocean and feel that quiet unease, that sense that something immeasurable is breathing beneath the surface, you are feeling what the Earth has always known, that every silence hides a heartbeat, and every death, a dream. The Triassic did not end. It only sank deeper. Even now, when you look out across the modern ocean, you are staring at a graveyard wearing the mask of renewal. Beneath its calm blue surface sleep the bones of every age that came before, layered like pages beneath the tide. Somewhere down there, the Triassic still hums, faint but unbroken. A resonance that threads through every living thing that calls the sea home today. Because extinction never erased it completely. It only changed its form. Some scientists call this continuity ghost lineages. The idea that certain species or fragments of their genetic code have slipped quietly through time, surviving unnoticed, invisible, until the world became ready for them again. It's not reincarnation, not exactly. It's endurance by disguise. And when we look close enough, the ghosts begin to reveal themselves. In 1938, off the coast of South Africa, a fisherman pulled up a creature thought to have been extinct for 65 million years. A coelacanth. Its fins were lobed like primitive limbs. Its eyes large and glassy. Its movements slow, deliberate. It was, by every definition, a Triassic relic. A fish that should have died with the dinosaurs, still swimming in the deep. Scientists were stunned. If one survivor could hide for that long, what else could be waiting? The deep ocean, after all, is the closest thing Earth has to time travel. Pressure, Darkness and cold preserve what the surface destroys. There, evolution moves not in leaps, but in whispers. The genes of ancient lineages linger, half asleep, passing unnoticed through centuries of adaptation. Even now, certain deep-sea creatures seem older than their age. Sharks that reproduce slowly, glowing jellies that use the same bioluminescent chemistry as organisms from the early Mesozoic. Some species have changed so little that comparing them to their Triassic ancestors feels like looking into a mirror fogged by eons. It's possible that the Triassic never fully ended, that its DNA survived, folded into the genome of modern life like a watermark only the ocean can read. The ammonites became nautiluses, their spiral shells enduring as mathematical prayers. The ichthyosaur's design reappeared in whales. Even the eyes of certain deep fish, tuned to the wavelengths of ancient light, echo adaptations from that long-lost sea. In this way, the Triassic is not gone. It's diffused. It lives in fragments of instinct, in chemical memory, in the pulse of migration patterns written across generations. The sea remembers through recurrence. It never repeats exactly, but it rhymes. If you were to dive far enough, past the reach of light, you might feel it. The temperature drop that signals entry into a slower world. Down there, below 2 kilometers, time behaves differently. The water moves so slowly it seems still, its density holding sound like breath. The creatures that drift through it glow faintly, their bodies soft, translucent, almost dreamlike. They are the ocean's living memories, adapted to survive in a place that has not changed since the Triassic twilight. We like to think that extinction is final, that when something disappears, it never returns. But the sea defies such certainty. It hides, it reconfigures, it borrows from itself. Every discovery we make only confirms how incomplete our understanding is. In 2021, researchers studying the deep-sea trenches of the Pacific found microbial colonies living inside basalt rocks that were more than 100 million years old. They were still metabolizing, still dividing, still alive. They had survived sealed away from sunlight since the age of the dinosaurs. And yet, they were thriving. Life, it seems, is less like a line and more like a circle. It loops, folds, and returns to its own beginnings. Maybe that's why so many myths speak of underwater kingdoms, sleeping gods, or serpents that circle the world. Perhaps our ancestors sensed something real beneath the metaphor, that the ocean holds a kind of eternity that we, as land dwellers, have lost. When we listen to the low-frequency hums recorded in the deep, the mysterious sounds known as the bloop, or Julia, or upsweep, we are hearing a world that refuses to reveal its authors. Scientists label them geological, tectonic, the sound of ice or shifting crust. But the uncertainty lingers. The scale, the depth, the rhythm, all suggest a living source too large, too deep, too old for easy explanation. It's not proof of monsters. It's proof that the sea still knows how to keep a secret. And perhaps the most haunting truth of all is that we ourselves are part of that secret. Our blood contains the same salinity as Triassic seawater. The ions that fire in our nerves, sodium, calcium, potassium, were forged in those same volcanic oceans. Every heartbeat, every tear, every breath that condenses into salt on our skin carries the echo of that ancient chemistry. The line between us and the creatures of that time is not broken. It's submerged. The ocean, in this way, is not just our origin. It's our reflection. When we stare into it, we are looking back at everything that has ever lived and everything that has ever died. We see ourselves in that shimmer, that restless movement, That blue uncertainty. There's a term in paleontology, Lazarus taxa. It refers to species that vanish from the fossil record for millions of years, only to reappear later, unchanged. Named for resurrection, these lineages are the ocean's defiance of finality. They remind us that extinction is only visible absence, not absolute. Somewhere, the Triassic might still be happening, quietly, out of sight. When the lights of submarines descend into the abyss, their beams cut through layers of silt like the thin hands of time. What they reveal are not just animals, but echoes, creatures that bear the designs of worlds long vanished. The coelacanth drifting near volcanic vents, the giant squid gliding like thought through darkness, the translucent octopus whose pulse glows through its skin, as if lit by memory itself. It's possible that what we call evolution is simply the Earth dreaming itself over and over, adjusting the details each time, but never changing the theme. The Triassic dream became the Jurassic, which became the Cretaceous, which became us. We are the latest translation of an ancient language still being spoken by water, when the waves crash and retreat, when the horizon hums at dusk. That's the sound of continuity. The ocean reminding us that endings are illusions. The Triassic Sea didn't die. It just sank into deeper water, waiting for us to find its reflection in the mirror of the present. And perhaps, when we finally listen closely enough, we'll realize the hum of the deep isn't alien at all. It's familiar. It's our own voice, echoing back from the beginning. Water does not forget. It moves, it changes form, it erodes and reforms, but its essence carries memory in silence. Every molecule that touches your skin tonight has traveled through veins of glaciers, clouds, blood, and sea, maybe even through the bodies of Triassic monsters themselves. When we say that the ocean remembers, we are not speaking in metaphor. Its chemistry is the same one that flowed through the bones of the first ichthyosaurs, through the gills of forgotten fish, through the lungs of every creature that rose to breathe. The ocean keeps everything, but never tells it twice in the same way. Scientists studying the isotopes in ancient sediments have found that water does indeed carry the story of its past. Ratios of oxygen and deuterium inside microscopic crystals reveal temperatures, rainfall, even the density of ancient atmospheres. These molecules are fingerprints of moments when the Earth itself changed direction. They show that the Triassic seas, in their cycles of warmth and suffocation, never disappeared entirely. They dissolved into the water that still surrounds us. Every rainfall, every tide, is a diluted memory of that age. But if water can store memory chemically, perhaps it does so emotionally too. There's a reason why humans, surrounded by waves, often feel nostalgia for something they've never known. Standing beside the sea evokes longing, calm, and an ancient recognition that no language can name. Psychologists might call it biophilia, the innate love for natural systems that created us. Yet poets have said the same thing for centuries in simpler words. We belong to the water because the water has never stopped belonging to us. Imagine, for a moment, the Triassic Sea as it might have felt from within. The light breaking through in green ribbons. The weight of the water pressing evenly across the body. The sound of one's own pulse merging with the current. The ocean was not just a setting for life. It was the first consciousness Earth ever had. Its tides were thought before thought existed, an intelligence of flow and adaptation. Every ripple in that sea was a calculation of physics and chance, but also something more mysterious, a dialogue between the planet and its living skin. The rocks confirm this in ways almost mystical. Some Triassic sediments display rhythmic layering called varves. light and dark bands deposited by seasonal changes. These layers are like the ocean's heartbeat frozen in stone. Each pair marks a year. When counted, they form a pulse of millions, steady, patient, unbroken even through catastrophe. Even when life nearly vanished, the ocean kept breathing. Perhaps that's what memory really is. Not recollection, but rhythm. The persistence of pattern even after the meaning is lost. There are myths from nearly every culture that tell of great floods, of worlds drowned and reborn, of civilizations swallowed and cleansed. To some, these are allegories of morality or divine wrath. But to the earth, they are memories. The Triassic floods, the anoxic seas, the slow drenching of continents. All of these are the ancestors of those stories. Somewhere in our species' collective unconscious, we remember standing on a coast that no longer exists, watching the horizon burn red as new oceans were born. In that sense, memory is geological before it is human. And water, being the oldest archivist, carries those impressions without bias. If you could listen to the deep currents today, far below the surface where sound travels faster than light through air, you would hear the ocean speaking to itself. Scientists record these voices with hydrophones, low, resonant hums that travel across entire hemispheres. They are not only the songs of whales or the grind of shifting plates. They are the pulse of temperature and salt, the friction of ancient motion, the rhythm of the Earth's rotation transferred into tone. Some of those frequencies have been continuous since before the first mammals appeared. The planet hums to itself in the key of water, and when that sound reaches the continental shelves, it stirs silt, wakes plankton, nudges coral spores toward light. Tiny acts of renewal driven by the faintest vibration. The same processes that built the Triassic seas are still building this one. The memory of flow becomes the instruction for continuity. The Japanese have a phrase, mono no aware, the gentle sadness of things, the awareness of impermanence. The ocean embodies that truth perfectly. Every wave collapses as soon as it rises, yet its collapse gives birth to the next. The Triassic waves that once broke on Pangaea's shores are gone, but the motion they began has never stopped. Each new tide is a translation of that ancient pulse. In this continuity lies something almost sacred. When paleontologists extract water from inside a mineral crystal older than 200 million years, they are not simply measuring data. They are holding a drop of time. Some of those trapped fluids still contain traces of the original ocean. Chloride, magnesium, even sulfur from volcanic vents that once poisoned life and then nourished it. To touch that is to touch a fragment of the Triassic directly, a whisper preserved inside quartz. Maybe that's why humans have always sought meaning beside water. We build cities along rivers, pray at shores, scatter ashes into waves. Intuitively, we return to the same place life first remembered itself, because somewhere deep down, we understand that what the ocean forgets, the world cannot keep. And yet, the ocean rarely forgets. Even our smallest traces, the chemicals, the plastics, the heat we release, are being written into its memory now. Future geologists, millions of years from today, might read the story of our time in those same isotopes and sediments. A brief fever, a layer of disturbance, a silence afterward. We will become one more rhythm in the planet's ongoing song. It is humbling to think that water that once filled the lungs of a dying ichthyosaur could now sit in a glass on your table, clear and quiet, unaware of what it has seen. It has passed through extinction and rebirth, through blood and vapor, through the veins of Earth itself. It has forgotten the faces, but not the feeling. So, when you drink, when you bathe, When you listen to the rain, you are touching time itself, time that flowed through monsters, time that built continents, time that drowned them again. The water remembers. It always has, and maybe that's why, when we sleep, we dream of waves, because the body, made mostly of water, remembers too. Every pulse of the heart, every rhythmic breath, every slow drift into unconsciousness is the sea reclaiming us for a moment, reminding us where we began. The Triassic may be long gone, but its tides are still moving inside us. The memory of water never dries. If the ocean remembers everything, then perhaps it dreams as well. Not in language or images, but in motion, in the sway of currents, in the slow turn of the moon's pull, in the way light ripples through water as if searching for what was lost. The Triassic Sea may be buried beneath epochs of silt and silence, but its dream continues, written into every tide that rises against the shore. And sometimes, when the night is windless and the stars hover like eyes over the horizon, you can feel it. That deep, quiet breathing beneath all sound. The sea that dreams itself. Scientists often speak of the living ocean, the idea that our seas are not separate bodies of water, but one immense organism, circulating heat, salt, and carbon as if they were blood. The theory isn't poetic fantasy. It's measurable fact. Currents in the Atlantic take centuries to complete a single circuit, sinking near the poles and rising again in the Pacific. A molecule of water can travel around the world and back within the span of a few thousand years. In that endless motion lies a consciousness of sorts. A planetary rhythm, as old as the Triassic itself. If the Earth has a soul, it is surely made of salt. When you look into the ocean today, you are seeing the same mirror that reflected the first reptiles to take breath. The same horizon that once held the silhouettes of ichthyosaurs surfacing for air. The creatures are gone, but the shape of their movement remains. Encoded in the patterns of dolphins and whales, in the gliding arcs of manta rays, in the long migrations of turtles that cross entire oceans without forgetting their birthplace. The sea rehearses its old choreography, never repeating exactly, yet never truly changing. To dream is to remember without knowing that you remember. The Triassic lives on in the ocean's unconscious. The curve of a fin, the rhythm of a tide, the shimmer of scales catching light at dawn. All of it echoes that first resurgence of life after extinction. Even the sounds of modern whale song, when analyzed, share harmonic frequencies with seismic patterns in Triassic rocks, as if the vibrations of ancient Earth still guide the music of living things. Coincidence, perhaps, but it is a beautiful one. The kind that makes you suspect intention hiding beneath chance. When paleontologists describe the fossils of those vanished creatures, their words begin to resemble poetry more than science. They speak of grace under pressure, of silence trapped in motion. Some whisper, almost embarrassed, that certain skeletons seem too perfect. The curvature of the spine too fluid, the symmetry too deliberate, as though nature itself were sculpting, not just selecting. They touch the stone gently, aware that what they're holding is not only evidence of life, but the imprint of a thought. Maybe that's what the Triassic Sea was. A thought made physical, the planet imagining itself alive again after near death. And maybe every age since then, Jurassic, Cretaceous, human, has been another sentence in that same dream. We tend to think of the past as something behind us, but the truth is, it flows beneath us, literally. The ancient oceans are still here, circulating through our own. The molecules that once carried the scent of volcanic islands or the heat of vanished sunlight are the same molecules that now wash against modern shores. We live on the surface of deep time, like foam riding atop a tide too vast to see. Sometimes, late at night, oceanographers lower microphones miles below the surface. What they record sounds almost like breathing. Slow, rhythmic, irregular. Pressure waves caused by far-off storms, earthquakes, the friction of currents. But to the human ear, it's something else entirely. It sounds alive. It sounds sentient. Some call it the ocean's pulse. Others, its sleep. If the sea dreams, then perhaps it dreams of itself, of the forms it once wore, of the giants that move through its body like thoughts. Dreams have no chronology. They fold time. In the same way, the ocean may hold every age at once, its deepest trenches remembering the Triassic, while its surface reflects the present. Every wave that touches the shore is both new and impossibly old. We will never know everything that swam in those forgotten waters. There are species whose bones were dissolved before they ever fossilized, ecosystems erased before the world had time to record them. Yet the patterns they left, in genes, in sediments, in myth, continue. When a whale dives, its body temperature drops by precisely the same gradient that an ichthyosaur's did 200 million years ago. When coral builds its calcium walls, it repeats the same atomic rhythm as the reefs that rose from Triassic lagoons. The continuity is eerie, almost tender. Life, it seems, cannot help but remember itself, and so, perhaps, can we. There are moments when human beings, standing at the edge of the sea, feel something ancient awaken. Not fear, not wonder exactly, but recognition. The rhythm of the surf aligns with the rhythm of our own blood, and for an instant, there is no separation between body and world. That feeling, fleeting as it is, might be the truest glimpse we ever get of what the Triassic Sea once felt like. Because the truth is, the ocean has never belonged to any particular time. It is not Triassic, Jurassic, or modern. It is eternal and always beginning. It is memory made fluid, the planet's unbroken consciousness, dreaming itself through every form, every extinction, every return. And when the last human leaves the shore, when our voices fade and our cities sink back into sediment, the sea will keep dreaming. It will take what we were and reshape it into something new, as it did with the ammonites, with the ichthyosaurs, with every creature that mistook endurance for permanence. The ocean does not mourn what it loses. It carries everything forward. So tonight, if you listen long enough, you may hear it. The soft, almost inaudible murmur beneath the crash of the waves. It is not the sound of water. It is the sound of time itself, turning over in its sleep. And somewhere in that deep and endless dreaming, the Triassic still moves, slow, luminous, alive. Its monsters no longer monstrous, but serene, as if the sea were remembering not its violence, but its forgiveness. Because all along, that is what it has been teaching, that even after the world ends, life does not stop. It transforms. It dissolves into memory, into rhythm, into light. The sea that dreams itself will never wake.